All right, we're going to work on scientific notation and standard form. So here we go. This is currently expressed as scientific notation. Scientific notation is a way for us to condense a number that is very, 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 very large or very, 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 very small. So I want you to take this scientific notation and put it into standard form, which is the way you're used to seeing a number. So it's really easy. So you're going to take this number right here. You're going to write down this number. And you remember the decimals here. You're going to move it 4 places to the right. So it's at the back. Why am I moving it right? Because that's a positive exponent, and positive exponents make big numbers. So what do I put right here? I put a 0. So that scientific notation equals that standard form number. So again, this number tells you how many times to shift that decimal and in what direction. Because it's positive, I want to make a big number. If it was negative, I would have went in the reverse direction to make a small number. So this is a negative exponent. That means I want to go in the opposite direction. That means I want to go left. So I'm going to write down the number, and I'm going to remember the decimals here. So I'm going to do 6 jumps to the left. There's 1, 2, 3, 4, 5, and 6. And the decimal goes right there. So what goes in here are all your zeros. Remember, negative exponents make small numbers. They make fractions and decimals. So that's all you're doing. So I went from scientific to standard form. So this one, you're going to go to the right 6 units, so I will add 3 zeros on the end of it. This one, I'm going to go to the left 4 jumps. So from here, this counts as 1 jump, and then I'm going to add 3 more zeros in front of it. So it's right here, and it goes 1, 2, 3, and 4 jumps. Easy. So now let's go from standard to scientific. So if you noticed on these scientific numbers, they all were being multiplied by a base 10. All of them were being multiplied by a base 10. See? Negative if it was a small number, positive if it was a large number. So I know that my rule will be this. Okay? It's a big number, so I know that the exponent is going to be a positive number. Now, the other thing I want you to notice on all of these that we just did, the first number is always less than 10, but greater than or equal to 1. Less than 10, but greater than or equal to 1. Less than 10, but greater than or equal to 1. Less than 10, but greater than or equal to 1. So I need to create a number. So the decimal is currently right here. I want to make a number that is greater than or equal to 1, okay? But it has to be less than 10, okay? So let's make that number. 1, 2, 3, 4, 5 jumps to make the number 8. I don't want to make 80. I don't want to make 800 because those don't fit the rule of less than 10. So this first number is created by looking at the primary number and how many jumps it would take to make that primary number other than 0. So take this one. Again, 2 lines, base 10. This time, focus in on the numbers. Create a number that is greater than or equal to 1, but less than 10. So 1 32/100ths. So how many jumps did it take for you to get the decimal between the 1 and the 3? So 6 is your answer. 1 32/100ths times 10 to the 6th. This time I know I'm going to have a negative exponent because it's a decimal. So again, focus in on the numbers, create a number that is greater than or equal to 1, but less than 10. And then how many jumps does it take to get from here to create that number? And put that decimal there. 2. And it's negative because it's a decimal. So try that one. Try each one of these. And here are your solutions. But I had to jump 4 to create 6.5. Focus in on these numbers. Would have had to jump 6 jumps to make this number less than 10. And then -4 because this number is a small number. Estimate how many times further Pluto is from the sun than Mercury. So you have Pluto and you have Mercury. Where's Mercury? Okay, so think about estimating this. You know, I would estimate this to be like 6 and this to be 6. So really I'm looking at 6 times 10 to the 7th, 6 times 10 to the 9th, and 6 times 10 to the 7th. I estimated, remember that. Cancel those. Remember your rule of same base, division, subtract exponents. 10 squared. Or could you say 100 times further? Approximately. And then we would do it again, but this time it's Pluto and the Earth. So here's Pluto, and here's the Earth, and you do the same process. This time you would find it's about 30 times. Because I would do, let me show you, I would estimate this to be 6 times 10 to the 9th, and I would estimate this only to be 2 times 10 to the 8th. Simplify this, you would get 3, and then same base, subtract exponents, times 10 to the 1st, which would just be 3 times 10, which would be 30. All right, so we're going to put these in order from in order of increasing diameter. Remember that the greater the exponents, the more zeros that would be tacked on, or the more movement you would make from your decimal. So 3-place movement for this one would be 1, 2, 3. 5-place movement for this one would be 1, 2, 3, 4, 5. And this one would be 1, 2, 3. So you can clearly see increasing in order of increasing diameters. This is the smallest, second, and then that's the largest. And then you do it again. Good luck.